Earlier in our security class, we saw the layer 2 device is the very uh, immediate or very first device where the intrusion begins. So that is where we have to provide more security, more focused. That's where we need to focus on security more than focusing on layer 4 and above. So a lot of attacks can be stopped right in layer 2 itself. For that, we have to identify the attack. To know the different types of layer 2 attacks, we have this chapter. And we saw in the first topic, MAC based attack, MAC layer based attack, in which we saw someone can flood MAC addresses into our MAC table, CAM table memory. As a result, the MAC table allocated space gets full and there won't be a new MAC address learning anymore. So when switch don't learn MAC address, what it will do, it will find every destination as a new destination, an unknown destination, because it's not learning anymore any MAC address. So whenever a packet comes, the destination of the packet will not be seen in MAC table because MAC table is already full and there is no MAC address learned. As a result, switch will start flooding. That is what we have learned. Any unknown packet comes, any unknown, it may be a unique packet, but the destination is unknown. If the destination is unknown, switches will always flood. This we know very well. So, because the MAC address is no more going to be seen there for any packets that comes, the legitimate packet that comes, as the attacker has fully consumed the total space, switch is going to be acting like a hub, always forwarding, flooding all packets to all. One of the device in that switch that floods is an attacker's device. Now he has got access to all the data, all the conversation that goes between A and B. Not only between A and B, there may be many A and many legitimate devices. There's one attacker sitting in your office as an employee. He gains access to all the data. Of course, there will be some slowness in the network. If there is a good engineer there in your office, he will be able to identify the slowness. Now, how do you prevent this MAC flooding attack? We saw that we can set limit to the number of MAC addresses that can be learned on a port. We call it as port security. Port security is a Cisco feature. When you enable port security on a port, that port will not allow more than one MAC address to be learned. So attacker now cannot send millions of MAC addresses. He cannot send numerous invalid MAC addresses anymore. So whenever a new frame comes, the source address is copied. Now, no device can send more than one source address. When a port security is enabled and then second source MAC address comes on a port, the port will go to shutdown state. It will get shut down. We also saw in the lab, we did a lab and we saw that there are also other two modes, protect and restrict. Restrict keeps the attacker away. For example, if I say port security, you may allow maximum 3 MAC address. If I'm sure there are 3 legitimate devices connected, I'll say allow 3 MAC address. What happens if the 4th MAC address comes? If it is restrict, it is going to ignore the packet with the new MAC address which is not within the 3 limit. It's going to ignore the first 3 will be continuing the conversations, whereas in the previous one, the shutdown mode, the port gets shut down. Not only the attacker is prevented from access, even the legitimate 3 guys also gets denial of service. So violation mode, shutdown is the default, which is going to stop even the legitimate people entering into that port. Restrict anyone who violates, meaning if you say 3 MAC address is the number of MAC address that can be learned, and if you can also specify either using sticky method or manually giving the 3 MAC address, allowable 3 MAC address, and the 4th MAC address which is not in the list comes, the violation action is going to be shut down by default. If you make it as restrict, the packet is going to be simply ignored. Shutdown will not happen, so the legitimates are still enjoying the service. When I say protect, it not only ignores the violator, it also increments the violation counter. That violation counter will generate syslog messages. If you will have a syslog server connected to your switches, you'll start seeing some logs, warnings, alarms. Verification command show port security. Here it says these are the 3 ports where the port security is enabled. And these are the number of MAC address that can be learned on this port. We have configured as 11. By default, it is only 1. Currently, 11 MAC addresses are learned already. So if the 12th comes, it's going to shut down. Whereas in this port, you have a different policy if the violation happens. If the current MAC address goes more than 15, that's the 16th one is going to be ignored. Here, when this number goes beyond 5, the violation counter increases. The first 5 will be still enjoying the service. Not only that, a syslog message is going to be generated for every violation. This is where you can see the violation count. Alright, so this is the command to see what all MAC addresses that are learned on the port where the port security is enabled. These are all the ports where the port security is enabled. We saw in the previous slide. In some ports 11 MAC address, some ports 15 MAC address, some port 5 MAC address. This shows that on this interface there are 1, 2, 3, 4, 5, and in which these 3 are configured manually. These MAC addresses were inputted manually, and these 2 were dynamically learned. On these 2 ports, we see manually given 3 MAC address. Just 2. Now, in this, none of the MAC addresses are sticked dynamically. You can use the keyword sticky to stick it so that it gets saved to the NVRAM. So when you restart the switch, there is no need of again giving the MAC address or learning MAC address. It's already learned and sticked. Then we saw AAA. If there will be a AAA server in your organization, how to enable AAA service on the switch? This is what this topic is intended. We are not learning AAA here. This is not a security class. Switching. So we need to know what need to be configured on the switch so that you can use the AAA service. When someone tries to log into the switch, either via telnet or SSH or via console, you want to authenticate them. Not only this switch, you have many switches. Instead of putting security user IDs and passwords on every single device, we have this server in which we put the authentication credentials, and we'll tell all the switches to use that authentication server to authenticate, the AAA server to authenticate. Two protocols, TACAX plus SS codes, which uses TCP, which does authentication, authorization, accounting separately. The other one is Radius, which operates on UDP. It does authentication and then authorization and accounting together. So on the switch side, we need to know how to configure AAA. The command is AAA new model to enable AAA service, which is not shown in this page. Followed by, you need to say the method, AAA authentication when someone log in, and you say default, it means for AAA is for console, telnet, SSH for all logins. The method need to be used is radius. And if the radius is unreachable, the method you need to use is TACAX. If both are unreachable, the method you need to use is method 3, local database. You can have these methods, but it will be checked same as you configure. If you say method 1 is TACAX, it will go only to the TACAX server. For that, you need to provide the IP address of TACAX server and the pre-shared key to get authenticated when you approach TACAX server. Likewise, TACAX server also, the security engineer will put the IP address of the switch and the pre-shared key. Once authenticated, then only the AAA services will be provided by the TACAX server. Same also with the Redis. This thing we have done as a lab in the previous class. There is also one more called .1x, which gives the authority to the switch to authenticate any traffic that wants to pass through the switch. For this, an additional software is required for you to control. To be a AAA client, you need an additional application. But on the switch side, this is what the command we need to enable .1x. So if someone tries to enter in through this port, the username and password will be verified before they pass through the port. Next chapter is about VLAN attacks. Based on VLAN, we can have VLAN hopping attack. Basically, the VLANs are to isolate traffic. It is good, but when we have a lot of VLANs with the different departments in our organization assigned, using the trunk which has got access to all VLAN, someone can hop between the VLANs. That is possible only if we leave the port in a dynamic auto mode. If we leave the unused ports in dynamic auto mode, someone can connect their switch or a PC which is spoofed as a switch, as you see in this picture. The attacker's PC is negotiating trunk, which proves that the PC is pretending as a switch. The attacker is using some software to do this. Yeah, so to avoid this, we have to go and put all those unused ports to an unused VLAN. We need to create a VLAN and use that VLAN only to put unused ports. That's one way. Second thing you need to do is put those ports in an access mode. Don't leave it as dynamic auto. Now the attacker, if he negotiates trunk, will that be possible? Not possible at all. So putting into an unused VLAN and shutting the interface and also making the interface as an access port prevents this VLAN hopping attack. Only when attacker gets the trunk negotiation successful, he can see the VLANs that you have and he can jump between the VLANs. So make sure the attacker never forms trunk via unused ports. This is one way of hopping between VLANs. The attacker is using some software here and sending some packet. He want to dump some packet in all the PCs of all VLANs. So here there are two VLANs. Attacker is choosing to do that. You want to dump something, kind of spyware or something. He's doing double tagging. First he is putting VLAN 10 and then VLAN 20, double tagging. When the packet approaches the trunk port on the switch, takes the packet in VLAN 10, and when it is going out via other port, that port processes it and considers the packet as a member of VLAN 20. And that's how this man, the attacker, gains access to VLAN 10 and 20. We call this double tagging. Even this attack also can be prevented by putting all the unused VLANs in an access mode, unused ports in an access mode, assigning to an unused VLAN, right? So these are the commands. You know these things. It's not a big switchboard mode access, switchboard access VLAN, unused number like 7778888. VLAN ACL works with both MAC ACL as well as route ACL, RACL. Like we have route ACL, we also have MAC ACL. Now you can call those ACLs under this VLAN ACL. This is the command that we use. VLAN access map, and we give a name. We call either layer 3 access list or layer 2 MAC access list. If the match happens, we say action need to be drop or forward or redirect to some other port. At last, we need to apply somewhere this access map. This is just creating access map. That's not enough. You need to apply it. Where you apply? Apply to a VLAN, a list of VLANs. VLAN filter, call this map name which you gave here, and then specify the VLANs that you want this action match and action to be taken. Right, that's VLAN AC. Then we also saw private VLANs. Let's have like 15 minutes break. I am not that good feeling well. So 15 minutes break after we'll see private VLAN and then we'll get into spoofing attack. Is it okay, Seth and Girish?
Yeah, sure,
15 minutes.
sure.
Yes.
Yeah, sure.
Thank you. நான் ஃபோன் பண்ணி எங்கே இருக்காங்க கீழே அதுக்கு நான் பிரேக் விடணும். இப்போதான் எனக்கு உடம்பு முடியாதனால நான் பிரேக் விட்டேன் ஒரு 15 நிமிஷம். இப்போ நான் பிளான் பண்ணி பிரேக் விடணும் அவங்களுக்கு கூட்டு வந்துக்கலாம். जी काफी पुट्टिया एक I'm back. Sorry, took some time. Seth, Girish, are you there? Seth, are you there?
Hi,
Hi,
sir. I'm
Girish.
here.
Hello,
Hi.
sir. Hi. Hi, I got
That's okay.
disconnected.
That's okay. Right. I have shared my screen again. Let's do one thing. Let's finish this theory and then we'll get back to the lab. We'll go to the lab. Um, spoofing attack. What is spoofing? Someone is pretending to be someone. Someone is pretending as other one. No, that's what spoofing is. So when someone spoofs a MAC address of other or IP address of other, we call it a spoof attack. Because he is pretending like someone, he gained access. How do we mitigate them? Is what. So there are a chain of topics now going to come. The first topic is important for the next two topics to work. The first one is a DHCP spoofing attack. DHCP works like this. It sends a layer 2 broadcast packet called discover. Who sends? Client sends. Client do not know who the server is. Your laptops don't know who the server is. Your laptop is a client. It needs IP address from the DHCP server. So laptop sends a layer 2 broadcast packet. It's definitely a broadcast packet. Don't have any confusion here. Some documents will say this is broadcast, that is unicast. This is, no, I have sniffed the packet. I've seen many times these packets. Using Wireshark, they're all layer 2 broadcast packet. When we have helper address and when you sniff behind routers, then you will find unicast. So some documents confuse you. I'll give you a clarity on that. Let us first finish what is normal. Client sends a discover packet, it's a layer 2 broadcast packet, which means the packet will be forwarded via all the available active ports of the switch. So this is a legitimate client. This is a real client sending a broadcast. It reaches the switch, and this switch will also send the broadcast. That is how this switch receives it. This switch will also do the broadcast. That's how it comes here. Spanning tree prevents by going back, but this one which is coming like this will be sent. So you can see the single broadcast packet getting replicated and flooded throughout the topology. But we know about the layer 2 control plane called spanning tree, which is going to prevent loop, though it is flooded. So we will not get into spanning tree now, which we already know. So the flooded packet will definitely reach everyone in the network, including this attacker. Attacker is waiting for this type of incident. Attacker is very happy because he is getting an discover packet from a client. Now he wants to pretend as a DHCP server so that if attacker is accepted as a server, the server can now give an IP address, the gateway, and the mask, and the DNS, and the Win server address, all to the client. So from that minute onwards, from that moment onwards, the client will always go through the server for anything. Because server has given his own address as a gateway, his own address as a DNS. So if this attacker has got a fake DNS server, not a real DNS server. So when client requests for a standard chatted page, this fake DNS will give a fake IP address of the fake server called standard chatted. So now the poor guy who don't know this, he is seeing the web page from this fake standard chatted, and he see a login, and when he tries to put the user ID and password and say submit, this attacker already captured the username and password. After this, the client may get some fake page, or sometime he will get page cannot be displayed if the developer of this attacker's company did not develop the second page after the login page. But what the pathetic thing here is, the username and password that client was using here is already revealed to the attacker. This has happened even to me. So, but it was not because of DHCP spoofing. It somehow they got my username and password, and they spoiled my life. For last 3 years, I am not broke. They thought I will be broke, but again I am coming up with better strength. So it is easy. This is one of the way which can be possible. Today it is much easier than what I am saying. Today you get an email and you open the attached file in the email and you are done. But service providers are working really hard to prevent this type of attacks. If you ask our security engineer, Mr. Arun here, he will say to prevent this, we will use WSA, ESA, more specifically ESA, email security appliance, to see the malicious attachment to a mail. Like this is another one. This is basic one. This is layer 2 related attack. Right in layer 2 itself, you can prevent this if you can prevent this attacker giving you the offer packet. See, the response to the discover is offer. Discover was sent by client as a broadcast. Offer is also sent as a broadcast by the server. So before the legitimate offer comes, this comes quick. So what this client machine will do, it will prefer the one which came early. So the client sends the request as again layer 2 broadcast to the server, to the server's MAC address. And server receives it. Not only server's MAC address, he will even know the server's IP address. Even though he knows the IP address, it is still a broadcast because he don't have an address to source, IP address to source. He has got only a MAC address to source. So client sends the request to the bad guy, and bad guy grants an acknowledgement saying you can use this what I have offered. So in this offer place, it is offering an address and saying if you are willing, you can take my IP address. What do you say? If you say yes, I'll block it for you. And client is saying, yeah, I request you to kindly block it for me. Then immediately this guy acknowledges, fine, yeah, I have blocked it, you can use it. Congratulations. So this is also a layer 2 broadcast. And client will start now using that IP address, the subnet mask, the gateway, the DNS address given by the attacker. Very pity, on the client. To prevent this, we can alert all the switches saying, if anyone is giving offer on an untrusted port, put that port in an inconsistency state. That is what going to happen. So we will just go to this port and say you are a trusted port, and on to this port, and on this port, and on this port, and on this port. We will say these ports are trusted. All these ports are trusted. All the rest of the ports are untrusted. What does it mean? All the end device connected ports are untrusted. Except the ports on the path, all the rest are untrusted. Untrusted. An untrusted port will not accept any offer or acknowledgement. They don't accept this. Only a trusted port will accept this. So this guy now cannot provide an offer, neither an acknowledgement. To do that, we need to enable DHCP snooping. Snooping will put all the ports untrusted. You go to the port which you want to trust and say, I trust this. DHCP snooping trust. All the rest untrust. All the one in the path. You say DHCP snooping, I trust, I trust, I trust, I trust. All the other ports in the connected to the switches, except these ports in the path, all other are untrusted. Is this untrusted? Of course, this is an untrusted port. This is an untrusted port. This is how we can prevent this middle guy attacking us. That's why this is called man in the middle attack. Right? So only a trusted port can provide offer and acknowledgement. DHCP snooping allows the configuration of the port as trusted or untrusted. Untrusted ports cannot process DHCP replies. What is DHCP reply? Offer and acknowledgement of the replies. Request is going as from the client for what? As a discover and request. Configuring DHCP snooping on the uplink to the server, do not configure DHCP snooping on the client port, meaning you make trust on all the uplink ports towards the legitimate DHCP server. This is the command to enable the feature. This is the command to say, I trust this port. Go to the legitimate DHCP server port and all other upstream port in the path and say this command. At last, you need to enable this for the VLAN or VLANs. This is an optional command. This is an optional command. So in some version of operating systems, you need to do this command so that the messages of DHCP snooping informations will be carried in the layer 2 extension field called optional field 82. But nowadays it is enabled, you don't need to do that. This is to set the number of DHCP packets accepted on a port. See, when there is only one DHCP server, you know how many offer will come. Only one will come. If you get more than that amount, then there is something extra, some attack sitting. Again, these things are not needed. See, this is the number of packets per second expected from DHCP server configured on this port. This is not a trusted port. You can increase or decrease this. Right, source code is same like not same. It's the source code is going to use the DHCP snooping table that gets built on every switch. So because we enabled DHCP snooping in the previous topic, now the switches know for which client what IP address is given. Switches know very clearly for a MAC address, let's say AAA, IP address 10.1.1 is given. So all the switches know this information. Now, if someone spoofs their IP address and say, I am 10.1.1.1, let's say this guy is saying, I am 10.1.1.1, actual 10.1.1.1 is this. If this guy says, I am 10.1.1.1, because it's an untrusted port, it will verify with the table. Is he really telling the truth? Is a source. The IP address that he is saying is correct. Switches can do this. Switches can check the layer 3 address of the packet. If it is matching with the table that is built on DHCP snooping table, it will allow, otherwise it will. Okay, IIP DHCP snooping need to be enabled so that the table can be built, and then for the VLANs, IP verify source, VLAN, let's say 10, DHCP snooping for security. So when you do this, it will check every packet that comes for the source. Next is ARP spoofing. So ARP spoofing is when an ARP request is sent asking for the MAC address of some destination by giving the IP address. Instead of the genuine destination, if someone in the middle pretends like a destination and replies with their MAC address. See, switches need only MAC address to forward the packet. When this computer A is asking for the MAC address of 10.1.1.1, which is here, this request is going as a layer 2 broadcast. Now, for 10.1.1.1, this guy replies and says, MAC address is BBB. So in this ARP table, the MAC address BBBB will be learned. So when A sends the packet, it will put the packet to the destination BBB, and packet goes here. Even though IP address is 10.1.1.1, the destination MAC address is BBB. Switch will also forward the packet this way because this guy only responded. But the original MAC address is CCC. Same as he did with A, B. This bad guy also does this spoofing thing with C. To C, he says 10.1.1.2, which is actually AAA, but gives BBB to C. C also learns this wrong address to reach A. So A and C, they send the packet to B thinking they're talking to each other. A thinks I'm talking to C, but actually A is talking to B. C thinks he's replying to A, but he's actually replying to B. When B is just swapping the packet. The gain is B gets a copy of every conversation that goes in between C and A and C, which can be prevented with the same concept that we enabled earlier, DHCP snooping. DHCP snooping table knows what real MAC address is for 10.1.1.1 because this IP address is learned initially from a DHCP server. DHCP servers gave 10.1.1.1 to CCC. It is recorded in this table here. So when you enable dynamic ARP inspection, all the ports are untested. When this guy says for 10.1.1.1 MAC address is BBB, the switch will get very angry because according to the table it is CCC. How dare you tell a lie? So I put you in a inconsistency state. Switch identified that this guy is an attacker because he's telling lies by comparing to the table. That's what you see. On all the untrusted port, when an ARP reply comes, it will check the genuineness of the reply against the table which it has already got. All the untrusted port will go under the validation. But all the trusted ports, this is a DHCP server. There is no chance for the switches to know the IP address and the MAC address of DHCP server. Because DHCP server did not receive IP address from anywhere through DHCP service. For that, there are two ways. One, you make this port as trusted. So when reply comes, no one will verify. Or you go to all the switch, add the DHCP's IP address and the MAC address to the DHCP snooping table manually. This is the command to add it manually to the DHCP snooping table. Or you make it as trusted port so that validation won't happen for the genuine device that you have. This is the command to enable IP ARP inspection for the members of the VLAN or VLANs. Right, so that is ARP spoofing. It prevents the man in the middle attack based on the MAC address and the IP address. So far we have seen MAC flooding attack, we have seen VLAN hopping attack, DHCP spoofing, ARP spoofing, IP source guard, and we have seen the mitigation techniques like port security and AAA, .1x, private VLAN, DHCP is snooping and ARP snooping, ARP inspection, dynamic ARP inspection. Right, so let us go to the command line and see the configuration part of the private VLAN, which we saw in the first session today. And then we'll get into new syllabus. So this is the plan, the PC on the above. PC5 and VPC6. They are going to be member of the primary VLAN, and they're going to be Prometheus port. Prometheus port will have access to all the secondary VLAN, both isolate as well as community. The two PCs in the left, 3 and 4, will be our isolate. Secondary. Here they are using 200, I'm using 101, that's the difference. Not much. And this is going to be VLAN 102 community. These two are going to be the member of VLAN 100. Promiscuous. CUOS, right? CUOS, correct. Promise. So not only this port, even this other port. For testing, I have taken these PCs. I'll call this as standout 0.0.0.23. What I give a name it can take. It is okay, I'll create a text 10.0.0. For here. One here. 2, 5. How is the plan? Let me start. I'll start from the PC. put IP address for test. IP 10.0.0.1. The mask is 8. There is no gateway. IP 10.0.2. IP 10.0.0.3. Uh-oh. Sure. It's okay. Even if you don't say the mask, it's okay. It is being it's taking slash 30 slash 24. No, I want 8. No, we're giving 8. So I want 8. All right. Okay. 5, 6, 3, and 4. 5, okay, 5, 6, 3, 4, 0. No, this one. Okay, the pieces are ready. Now let's go to the shoots configuration. First of all, we need to create the VLANs. I'm going to say a VLAN from 100 to 102. 100, 101, 102. 3 VLANs created. Now I'll go to VLAN 100 and say private VLAN primary. Right? Private VLAN can be configured only when VTP is transparent or off, or version 1 or version 2. Wait. Private VLAN can only be configured on VTP in a transparent mode in VTP version 1 and 2. So either I should make these two as transparent mode or I need to switch to version 3. Alright, so let me make version 2 transparent. VTP mode transparent. Now if I give the command primary, it accepts. VLAN 101 private VLAN secondary private VLAN not secondary, we say isolate, and then 102 private VLAN community. Then what is next is we need to map these two VLANs to the primary. So VLAN 100 again, private VLAN primary, no, private VLAN associate. First we need to provide the VLAN IDs and say 101. Come on, wait, I need to check this in. Private VLAN associate, I need to use the add command. So I say VLAN 1, if I say like this 102Y, just not accepting. Okay, yes, it has accepted it. Sorry. See, what I did is I went inside VLAN 100, which is already defined by as primary. I added this association. So these two are secondary to that. Now if you type show private VLAN, show VLAN private VLAN. Now you can see 100 is a primary to which both 101 and 102 are associated. So what we have to do is we need to go and configure under the port these VLANs. So I go under interface, please pay attention. On interface 3, we want permissions. It's a permissions, it's not a host port. So the command, we have done all this thing, okay? Now the command that I have to use is this. Go under the interface and say whether it's a host port or permissions port. Okay, now I'm going to say here interface Ethernet 0/3 switch port mode private VLAN permissions. Whereas on interface Ethernet 0/1, I have to say switch port mode private VLAN host. Also on interface Ethernet 0/2, switch port mode private VLAN host. So we have defined the ports, but we have not said to which VLAN they belong to. The syntax is host association, and then I need to say the VLAN number. For that, first I need to say primary and then followed by secondary. Say we have already defined VLAN 101 as promiscuous. We want this to be, as 101 as isolate. We want this to be an isolate. So I go under interface range Ethernet 0/1-2, and I'm going to say switch port mode, not mode, switch port private VLAN host association. The primary VLAN is 100, followed by this particular isolate VLAN is 101. That's all. So that's what here it is said. Switch port private VLAN host association primary, followed by secondary VLAN. Likewise, I need to go to the Prometheus port and say private VLAN mapping command. Okay, so the interface is Ethernet 0/3, switch port private VLAN mapping command. Mapping the primary VLAN first, which is 100, and followed by the secondary VLANs. They are 101, 102. You can see the syntax. Primary VLAN mapping, first the primary VLAN and then secondary VLAN list. That's all. Now let us go and verify. Show VLAN, private VLAN types. You can see VLAN 100, primary VLAN 101, isolate community. When I remove this, you can see the members. See Prometheus, members. These are promiscuous members. 1 and 2. Who is 1 and 2? They're also member of isolate. They can see 1 and 2 are isolate VLANs, which can also talk to promiscuous 100. We don't have community in this switch. We don't have community in this switch. Community is here. We'll have a trunk link in this port. Interface Ethernet 0/0 switch port mode trunk. Switch port trunk encapsulation .1 switch port mode. So whatever we're supposed to do on switch 1 is already done. Now moving on to switch 2. Switch 2. Interface Ethernet 0/0 switch port mode trunk. Okay. Switch port trunk encapsulation .1 switch port mode trunk. Now you see, if you would have had BTP version 3, the replication of those VLAN role, primary, secondary, would have been already distributed. But because we are doing version 1 transparent mode, that replication would happen, we have to do manually. So VTP mode transparent here also, otherwise you cannot have private VLAN if it is version 1 and 2. Now, interface Ethernet 0/3. Wait, before that, VLAN 100, private VLAN primary. There is no command called promiscuous here. Only on the interface you will have promiscuous. Next, VLAN 101, private VLAN isolate, which is not a member of the switch anyhow. In case in future, if you will add a member of an isolate, we can use this. That's why I'm creating. Next, VLAN 102 is what we have determined to use as secondary or community. I'm saying that private VLAN community. Next, I need to go back to VLAN 100 and say private VLAN association. First is the primary VLAN. Sorry, we are also already inside the primary VLAN. Association 100, 101, 102. Next is we go under the interface Ethernet 03 and we'll say switch port mode private VLAN promiscuous. So now, so far we have finished half configuration on switch 2. Let's go to interface Ethernet 01-2 range. Switch port mode private VLAN host. Switch port private VLAN, and I need to say map. Yes.
Sir?
Association host. Sorry, wait a minute. Switch port private VLAN mode. No, not mode. What's the command? Switch port private VLAN. Switch port mode private VLAN. Mode private VLAN host. And this belong to VLAN 200, so switch port private VLAN. First the primary, followed by the community VLAN 102 associate. First the primary, followed by community. A command. This host 100. If you put question mark, it will say primary VLAN, so 100. And then the second page is 102. Alright, so we have completed the configurations. This is done, this is done. Show interface private VLAN mapping. Let's check this command. Show interface private VLAN mapping. I don't see any private VLAN. Interface secondary VLAN type. Show VLAN private VLAN. I can see these two are mapped to interface 102. I'm seeing here mapping, but I don't know why. The previous command did not show me. Show interface private VLAN mapping. Surprise. I just want to check whether I have the permissions properly configured. Show run interface Ethernet 0/3. Switchboard mode private VLAN permissions. It's there. No, even here also we need to map. Interface Ethernet 0/3. Switchboard mode private VLAN. Switchboard private VLAN. Here the associate command will come. This is committing permissions port. Have a permissions port. Okay. So where are we?
Sir, I think
Oh,
switch 1 is 0/3 is not promiscuous.
that we'll check, but still I was stuck with something before that. We did this.
I remember switch 1 we configured
It's okay,
only
it's
two
okay. That
interface,
part we'll
1 and
check,
2.
but that is not the one we are trying to figure out.
Okay.
Uh, that is not the part which I'm focusing on. Switchboard access VLAN 100. Let me see now. I'm not able to see. Okay, you want to check switch one? No, I have configured, but anyway, I'll show it for you. I want you to see that. Show run interface Ethernet 3. Okay, I remember I configured this. Okay, so the correct. The Prometheus command is not given. True. So we have to say interface Ethernet 0/3 switchboard private VLAN switchboard mode private VLAN Prometheus. And now let's verify. Okay. Now this command is not given
Okay.
on switch 2. Show run interface Ethernet 0/3. Okay, this is not really needed. I should remove this. The mistake I have put. Now let us type this command show private or show interface. Show switch port interface. Show interface private VLAN map. Huh, again, it's not showing anything here. Show private V, show switch port private, show VLANs. Okay, now it looks good. If you see the, if you see this, Prometheus have got, this is Prometheus port. Prometheus have got rights to talk to both the isolate members. Very nice output. Like this, Prometheus can talk to community, but we don't have community right now in this switch one. But in switch 2, we have community members. So if I type this in switch 2, you can see that 03 is mapped to community members. So this is a very nice output. I don't know why this operating system, I think the problem is with the operating system, it's not showing the interface of the secondary VLAN. But these are the interface of the secondary VLAN. Show VLAN, private VLAN interfaces. Do I have the command? This is the command that will show you. Also, if I type simply VLAN, I don't think you will see any output. See, there is no information about the private VLAN here. Show VLAN brief. There is no information about the primary, secondary, and all here. For that, you have to type only private. So if everything is good, then I should be able to ping from this computer to anyone. I can ping, but I will not be able to ping between these two. Same way, I cannot ping between this community members and the isolate member. Not possible. I can ping between the community members. You need to test this. You see? Hey, what is this? This and this should talk because they both are belong to Prometheus. No problem. That these two guys can talk to anyone. They can talk because they are Prometheus and they belong to primary. These two should not talk, and this group should not talk. But these two can talk. This can talk to this. They can talk. This can also talk to this. This is what we need to verify. Simple. Instead of talking too much, we should check this. When I ping from here to here, I should not ping. That one I should check because it's an isolate. But when I ping from here to here, it should ping. This is the first check we are going to do. Going to 4, trying to ping 3. Four is Ping 10,003. This should not ping. Very nice. Likewise, I should not ping 5 also. But I should ping 1, which is promiscuous. You see, it's pinging. And now, if I go to 5, I should be pinging 6. If I ping 6, it should 6. It should ping because it belongs to community. You see, it pings. This can also ping 2 and 1. See, it's pinging 1 on the other switch, 2 on the same switch. But it should not ping 3 or 4. That's all private VLAN. Right?